Homework 11, section 6.1, Discrete Random Variables, video 6. In the previous video, we created a probability distribution for the airport parking space scenario. Just a reminder, the probability that a space rented out for $2 per hour was 0.142. The probability that a space rented out for $4.50 per hour was 0.378. The probability that a space rented out for $1.50 per hour was 0.423, and the probability that a space rented out for $4 an hour was 0.057. The spaces were separated based on whether or not they were covered and whether or not they were short-term and long-term spaces. So how can we use this to make an inference about a population, as was alluded to in the previous video? If I own this business, I may want to know what can I expect to earn on hour for the average parking space. Well, not all the spaces are equally distributed, so I can't just average these values. Some of them occur more often, some of them occur less often. So how can we find the mean of a probability distribution? If you recall, there was a section prior to the first test where we were finding the mean for grouped data. Remember when we grouped everybody together? How many of you have a birthday between the 1st and the 9th? And I counted you, and then we forgot who said what. We just knew everybody was in that interval. And we had to calculate the average by doing some trickery and some sleight of hand. This is very similar to it. I'm not going to draw the strong connection between the two, but if you're curious, I invite you to compare what I'm about to show you to calculating the mean for grouped data. There's a formula for calculating the mean of probability distribution, and it's actually quite simple. To calculate the mean, all you have to do is find a sum. What are we going to add? A bunch of products. You simply multiply each value times its probability. Actually, I'm not going to put a capital X there. I'm going to put a lowercase x. Why? Because we're representing a certain value and not necessarily a variable. For example, x, this variable can equal this value, or this value, or this value, or this value. So this x represents the individual values, not the actual variable itself. Now, what does this sum mean? It means that for every possible value of the random variable, you're going to multiply its value times its probability, and then find the sum. For example, one value of the random variable is $2, and the probability of that value is 0.142. But we have to do that for every possible value of the random variable. Another value of the random variable is $4.50, and its probability is 0.378. So multiply the value times its probability. And the same thing for the next value of $1.50. Its probability is 0.423. And then the last possible value of the random variable is $4. Its probability is 0.057. So $4 times 0.057. Then you just get out a calculator and mash all the buttons. I'm looking to see if it's already calculated in here. No, so I will just get out a calculator and figure it out myself. All right, $2 times 0.142 plus $4.50 times 0.378 plus $1.50 times 0.423 plus $4 times 0.057. And if I pushed all the buttons correctly to the nearest cent, we get $2.85. So on average, this means that whoever owns this airport space, they average $2.85 an hour every time they rent out a space. So calculating the mean of a probability distribution is pretty straightforward. It's just this formula. Oh, one other comment about the mean. The mean is also called the expected value. On average, whoever owns this parking lot can expect an average of $2.85 per space per hour.